us on any of these Green Thumb lectures before, welcome, and thanks for joining us tonight. Normally, these lectures are taught by one of our Extension Master Gardener volunteers. I am going to be teaching today's because it's on soil, and that's one of my favorite things to talk about, and that is deeply in my background, but I'll talk about that in a minute. And I will go ahead and get started here. So let me, there we go. So today we're going to be talking about soil health and fertility. And to a lot of people, talking for an hour and 15 minutes about soil seems like a lot of time to be talking about soil. But to be honest, to try to fit soil health and fertility into that period of time was a huge challenge. So I studied agriculture, horticulture as my undergraduate degree, and then went back to school and got my master's/PhD in soil science, specifically in soil health. So I could talk for days, literally, about this thing. So having said that, I really tried to cover as many important topics as I could, but I also didn't want to kill y'all with soil science, and I wanted to be able to fit it all into our time period and also allowing for questions. So if there's something that you're interested in or that you still have a question about that I had to sort of gloss over, feel free to ask a follow-up question about that either during the presentation, and if I don't get to it, I'll certainly try to leave some time at the end. So some of this stuff may not be covered as in-depth as you want, but I'll try to fit everything in there. So what I am going to try to fit in to tonight's presentation is, like I asked you guys just a second ago, what is soil? It seems like a basic question, but it's, you know, an important starting point. And I saw some of the answers thrown in there, and they're great answers. All of them were right, and some people hit it really on the nose, and you'll see in a couple of slides. But also talking about, so what are some of the basic properties of our soil, and how does that affect how it functions and how we want it to function? And then we're going to shift gears a little bit and talk about that concept of soil health. So how is a soil healthy? Is it living, and what does that look like? And then we'll look at what healthy soils do for us. What do we expect from our soils if we keep them healthy? And some practices and management ideas for improving and maintaining our soil health. And then towards the end, before we are done, I do want to talk about soil testing and interpreting those results and being able to use the results of a soil test to manage nutrients. So it's a lot, and we will do the best we can to get through all of it. So what is soil? I just glazed through what you guys threw up there. I saw a lot of great answers about organic components. I saw, you know, it's a growing medium. A lot of you put something along the lines of it's what we grow things in. It's the basis of our garden or our farm. And absolutely right. And then I definitely saw a few people that have maybe looked into this before. I've had a soils class maybe, or looked it up on their own. But soil is basically a handful of things. At its core components, soil is made up of mineral components, organic components. And when we say organic, this is not like the concept of USDA certified organic, but organic, and when we're talking today, pretty much the whole time is going to be referring to something that instead of being a mineral or rock base, it's carbon based. So it's coming from something that is either living or was once living and has more of is made out of carbon primarily. And then you'll see here in this little pie chart that approximately half of soil is actually not particle at all. It's the pore space in between those particles and whatever is filling them. So you see the little dashed line or zigzag line here between the air and the water component. And the reason that is because those soil pores that we call them, whether they're big or little, are either filled with water or air, but it's a inverse relationship. So if we got a 3-inch rain the other day, then right after that it may be saturated, which means it's mostly filled with water and there's very little air in that soil. Or if we've been going through a droughty period, then it's all dried up and there's very little water, just a little bit clinging to those, soil surfaces, but not much water in those pore spaces. So it's certainly dynamic and it goes back and forth. And 5% organic matter would be wishful thinking for a lot of folks here in the Piedmont with a lot of this eroded soil, but this is sort of a general average of a good average soil. So within that organic matter fraction, it's also a little bit more complicated than that. So when we talk about organic matter in the soil, that could be anything from actual living little organisms that are in there, that counts as the organic matter, or things that have just died, or crop residue or roots from plants that were, just living a few days ago and are now sitting there in the soil, or stuff that's begun to break down, or stuff that's been, carbon matter that's been in the soil for years and years and years that's turned into what we call humus, or that sort of stabilized carbon organic matter in the soil. All of that makes up this little percentage slice. So the mineral components of the soil, a lot of y'all may have seen the soil pyramid. If you guys have never taken a soils class, you may not have ever seen the soil pyramid. But basically, this is an important primary component of soil, or property of soil, is soil texture. So if you hear somebody talking about soil texture, what they're talking about is the percentages of these different types of mineral components. And this is very important to the properties of soil and how they react to amendments, or maybe what amendments you may need to use in these soils. The particle components of soil are broken down by size. So we have clay, silt, and sand are the main mineral components of soil. And sand is the biggest by far. I'll put up this little picture here, just give you kind of an idea. So if this was a particle of sand, then the next biggest is silt, and it is much smaller here. It's really anything below sand and above clay, and then clay is very, very small. And if you're from this area, we're here in Athens, a lot of our soils tend to be somewhere in the sandy clay loam. A lot of people would just say it's just clay, and if you're out, sort of like our new building and something was just graded, maybe it's more of a clay than a sandy clay loam. But you just use the percentages here to figure out kind of where you fall in your soil. And this is important because of largely soil fertility is affected very much by these soil particles and what the texture is of your soil, but also water drainage and how you expect your soils to either hold or drain water. So an example that was always helpful for me, because I'm a very visual person, that one of my undergrad professors used years ago. We were in one of those big lecture halls, and he said, so if this lecture hall was a cup of soil and it was a sandy soil, then it would be like the whole hall being filled with beach balls. So you kind of imagine the ease of moving through something like that, and big spaces filled with beach balls. And then if it was a silt, it would be like the lecture hall being filled with frisbees. And then if it was a clay, it would be like the entire lecture hall, floor to ceiling, being filled with dimes. And these are not accurate differences in size per se, but it does give you that really real imagery of how easily or how difficult it would be for something to move through something as dense as a lecture hall filled with dimes. So in Athens, when on our clay soils, a big issue that we have is water drainage. And clays can be fantastic. I'm not putting down clays. If you have tried to garden in sand, they have their own issues. Clays are great for holding water, which is good. And they are really good at holding on to soil fertility and maintaining soil fertility. But if you have a really strong clay and not much sand or silt or organic matter, you can have very real drainage problems in your garden or in your farm that can lead to a lot of root rot, which is a common issue we see both in the landscape and in farms here. So that's something to consider. The texture is not everything that determines things like drainage and root ease that roots can move through the soil and water holding. There's also structure. So they're easy to get confused, but texture is the percentage of different types of minerals, and structure is the way that those minerals are aggregated together into different chunks and components. So structure is soil aggregates, and this picture is sort of an ideal, very nice picture of a very high organic matter soil with tons of aggregates, but it's very easy to see what we're talking about when we say aggregates. So there's large aggregates, like you can see here, these big chunks with the little roots moving through them, and aggregates can be teeny tiny, almost hard to see. but those soil particles being held together in these little amorphous chunks allows for these pore spaces that you can see in here, which is where the water drains through or where air pockets are held. And like I said, they're not all large enough to be visible like these, but even little bitty ones that we can't really see in here, they exist, these teeny pores where water can be stored or air can be stored and roots can move through. And so structure is extremely important, and it's also extremely important because we can affect it. It can be impacted by our management and how we treat the soil, whereas texture is really what most scientists consider kind of an intrinsic value of the soil. So unless you're making up your own soil mixture in a garden bed, if you're working in the ground or on a farm or landscape scale, you really can't affect the percentage of different minerals in your soil, but you can affect the structure of your soil and how well those aggregates hold up to disturbance and how many aggregates you have, and that will go a long way to improve the functionality of your soil. So there's some basic concepts to keep in mind as we move forward through the rest of this, but I do want to go ahead and start talking about the concept of soil health. So how can a soil be healthy? This is a quote from USDA Natural Resources Conservation Society from in the last 5 to 10 years, and it's just talking about the shift in scientists and policymakers we've shifted from the concept of soil quality to this concept of soil health, and they're very similar, with the main difference being that we want the new mentality of we are caring for a living system. So we refer to it as a soil health. Only living things can have health, so viewing a soil as a living ecosystem reflects a fundamental shift in the way we care for our nation's soils. Soil isn't an inert growing medium, but rather is teeming with billions of bacteria, fungi, and other microbes that are the foundation of an elegant symbiotic ecosystem. So a lot of what this talk is going to be about today, we certainly want to talk about how to keep your soils fertile and productive, but we're going to be coming at it from a viewpoint of this is actually a living ecosystem that you have in your garden or your landscape or your farm, and how do we care for it when we're thinking about it in those terms. And this is just to hammer it home in case you already weren't sure that you wanted to listen to another 40 minutes of soil health, but this is an article from the Atlantic in 2013 that I saw, and it was all about the soil microbiome, which is what I was starting to study at the time. So I saved the quote, and it says, "The single greatest leverage point for a sustainable and healthy future for the 7 billion people on the planet is arguably immediately underfoot, the living soil where we grow our food." So why is soil health so important? We're not going to be talking about it in terms of all the ecosystem services and it's a huge carbon sink and all these other things that it gives to society. But tonight we're really just going to be talking about, as growers, as gardeners, as landscapers, as farmers, what do healthy soils do for us and why do we want to keep them healthy? So one thing is they provide the right amount of water, and what I mean by that is what I was talking about earlier. We want something that will hold water so that we're not having to constantly irrigate or rely on constant rainfall, but we don't want it to hold too much water because it'll readily lead to root rot and disease issues. We want it to hold and release nutrients in a way that make them available to plants. So we'll talk about this more in depth, but soils serve an enormous purpose as a food web. As you put your fertilizers in there at the beginning of the season, and there's a very complex system and mechanisms that go into not only holding those nutrients in the soil and not releasing them into the groundwater or the air, but also making them available. They're not always in available form for the plants. So this is very complex and is largely driven by living things in the soil. They also provide a sturdy but permeable support system for plant roots to grow. So they're the actual growing medium for the soil, but they can't be too dense or compacted, and they have to be sturdy enough. They can't erode away. That's a huge part of soil aggregates, is maintaining soils that don't erode easily. And they also provide checks and balances to potentially pathogenic organisms. So talking about a living ecosystem, we know that there are plenty of pathogens and bacteria and fungi that can cause damage to our plants, but there are just as many and often many more organisms in the soil that are living alongside them in that ecosystem that provide a sort of balance and checks and balances to what could become a harmful pathogen. So what is in this living soil? We're talking about this is a living thing, it's a living ecosystem. What's in it? The soils are home to over 1/4 of all living species on Earth, and 1 tablespoon of garden soil may contain thousands of species, millions of individuals, and up to 100 meters of fungal networks and hyphae. So when I say it's living, I really mean most soils, you go outside and any soil you pick up a handful of has actually thousands of living things in it. It is largely a living ecosystem. And I've looked under the microscope, I'm telling you from firsthand experience, not secondhand experience. So what's in it, it's broken down into a whole lot of different categories of living things. We have on the smallest side, we have the bacteria, we have algae, we have fungi, protozoa, nematodes, arthropods, and earthworms. Nematodes, Joanna knows I would love to spend the whole talk talking about nematodes. This is what I concentrated on a lot in school, but I won't, I promise. It's basically, they're these little worm-like organisms. They're microscopic, but they're these little dots that you can kind of see next to the nematodes. A lot of those are bacteria, so that kind of gives you a scale. I included these pictures just to show you, I mean, there are actual zoos of things in the soil, that it's not just little dots and bacteria. So the picture on the far right here is called a monarchid nematode, and they're referred to as the tiger nematodes. And it's hard to see in this picture, but they actually have a set of jaws that shoot out of their mouth and can grab other nematodes or other little soil organisms and pull them back in and eat them. This one in the middle is it's a ring nematode. It's a common plant parasitic nematode, and you can see that sort of needle at the front of its head, and that needle comes out of its mouth, and that's what it pokes into plants to feed on. And then this one on the far left is a bacteria feeding nematode, and we'll talk a little bit more about their roles later in the soil food web. But it has these little whiskers on the top of its head, and it feels around and it eats bacteria. So there's very complex things going on, and these are all, I could go into anybody's backyard and find probably one of each of these in the soil, or a lot more than one of them. These are just for fun. There's not nearly enough of these probably to talk about at too much length, but I do see them. I mean, they are literally everywhere. I just like including them on here because I think they're a great illustration of what we just don't even know is beneath our feet and everywhere around us. These are called tardigrades, and a lot of people call them water bears. That's how they are originally described. But these things are amazing. This little picture, this is from like an electron scanning microscope, the little cartoon picture of it. But the picture on the left here is exactly what you would see if you just extracted some soil and looked at it under a microscope like we have here in the office. And they literally look like little bears, and they swim through the water. And these things can live at some of the most extreme situations on the planet. They've done experiments where they can live through radiation. They can live like in Earth's orbit. They can live at a pressure that's greater than being in like the Marianas Trench or something. So I just like including those because those are really there. I mean, the soil's like you might not even want to know what all is in your soil. Go. Next one. Springtails they're in the family Collembola. Come in a wide variety. I'm including them because they are present in huge numbers in most soils, and they're an important organism for decomposition and shredding and breaking down organic matter. You can see all these different little shapes and sizes that they come in. Arthropods. So arthropods means jointed legs. So essentially, we use the term arthropods for all of those jointed leg bugs with exoskeletons and things that aren't insects. So the arachnids, like the spiders and ants, and millipedes and centipedes, roly-polies fall into this category. And then these pictures that have the black background are actually microscope pictures of tons of different types of mites that live in the soil. So they're microscopic, you can't see them, they're teeny tiny, but many, many types of little mites that live in the soil and eat other smaller things and bacteria and organic matter. And then, of course, there's the earthworm, which is hugely important, a little more obvious to our naked eye, and we've all actually come in contact probably with earthworms. But these sort of larger organisms, these earthworms and the larger arthropods, play an important role in creating soil pores and aggregates and breaking down organic matter as well. So talking a little bit, we'll go through kind of quickly of what all of these organisms do in the soil. So great, they're all there, but what do they do? Starting sort of at the top here, by the way, this is a chart of trophic groups, which is just a fancy word of saying nutrient categories. So it's really just the way that each of these groups obtains their nutrients or feeds. And so in terms of a soil food web, how they all work together in the soil. So the photosynthesizers, they're plants, actual plants that grow in the soil. They're algae, and they're actually bacteria that can photosynthesize. And so these guys are like the primary. They can just create their own food out of light. Or your crops fall into this category, your ornamental plants. And then there's decomposers, which are things that break down already dead organic matter. So if something dies and you throw it on the soil, it's not just going to turn into something else on its own. It requires these microorganisms to break it down. And then mutualists are essentially something that have a relationship with something else to obtain their nutrients. Then, of course, there's pathogens and parasites. So we know what a parasite or a pathogen is. It's something that relies on a relationship from something else to obtain its nutrients, but it's not a mutual relationship. They're being parasitic and they're sort of taking advantage of something else, usually your plant. And then root feeders, self-explanatory. Bacterial and fungal feeders are what we consider grazers, and that's just a term that's used in the food web world. So the nematodes that we saw, and protozoa, and then some of the little mites, and even amoebas and things like that, they are extremely important in cycling nutrients, which I'll talk about just a little bit later. And they're all considered grazers. So they are feeding on these primary decomposers and cycling nutrients by eating them and actually releasing some of those nutrients. And then we talked about some of the bigger things like earthworms and millipedes and stuff like that, and they're referred to as shredders. So these little bacteria and fungi are really important to breaking down organic matter and returning it to the soil, but it's hard for them to do that if it's an enormous piece. So instead of one leaf, we're talking about little bugs and things breaking up something like a leaf or a twig into teeny tiny pieces that have a lot of surface area that can then be broken down by the bacteria and the fungi. And then the higher level predators are just predators. They're anything that eats something else, but usually stuff that's big enough to see. So again, I sort of went through all those. I kind of give away for the next couple of slides, and I won't spend too much time on these. The decomposition process, extremely important. It is the cycling of all of our carbon matter in the world from living to, so we don't just have a bunch of dead plants and animals sitting all over the place, but it's incorporated into our soil, which plays an enormously important part in soil health, the soil organic matter. And we'll talk about increasing that later. But I did want to sort of to give a scale of how much these decomposers do in our soil ecosystems. The soil organic pool, a lot of people talk about the oceans as a carbon pool when we're talking about CO2 and the carbon cycle, but the soil organic pool is the second largest carbon pool on the planet. And it's directly, that carbon is pulled into the soil by living things. And the estimate here is that every year soil organisms process about 25,000 kilos of organic matter in a surface area equivalent to just a soccer field. And I can't remember the megatons. I used to have that somewhere, but it's billions of tons in the soil organic carbon pool. So if you're a big greenhouse gas person, soils are extremely important. Talked about shredders already. The mutualists, I do want to spend a second when we talk about mutualists. A lot of y'all probably are familiar with some of the ones that we're talking about. These can be some of the more prominent ones are like mycorrhizal fungi that have associations with roots, so they can form relationships with the roots of plants, and what they do for the plant is that they extend the plant roots, you know, many times the size of the actual roots themselves in order to absorb nutrients from the soil. And a lot of times they can even access forms of nutrients that the roots wouldn't be able to access on their own. And in return, the fungi often receive carbon, like kind of sugar inputs from the plant roots, but they're scavenging and gathering all these nutrients in the soil, sort of like a big web, and giving it back to the plant. And then another really common example of a mutualist are nitrogen fixing nodules on plants. So like specifically a lot of legumes do this with bacteria. So bacteria will live in the nodes of the plant roots, and they will actually create usable nitrogen for them, fix it from the air and make it where the plant can take up that nitrogen. So it's like a little nitrogen factory. We talked about nutrient cycling a little bit. What I do want to say about this is we talked about the organic matter fraction in soil, and a lot of this is made up of fungi and bacteria, which are sort of these primary organisms, of which there are thousands in just a little teaspoon of soil. And so they themselves have to use nitrogen and other nutrients. They make it available to plants, but they're also going to use it and hold it in their own bodies. There's a natural cycling that goes on as they sort of just die on their own. But another really important way that these nutrients become available to plant roots is that these grazers, the nematodes and protozoa and mites, will eat the fungi and the bacteria and actually excrete usable nitrogen and phosphorus and other nutrients that is then sitting there right next to the plant root and ready for the roots to take up. And an interesting anecdote and sort of proof of this importance of this process is they've done studies where they've found that plants will actually exude, maybe not, a lot of plants will exude sugars from their roots, little carbohydrate-rich solution, which there's no reason to, they just exude it into the soil, letting go of this energy that they created, with the express purpose of attracting bacteria and things to come take up those sugars. And then those bacteria, all feeding there, attract things like nematodes and other grazers that will eat the bacteria right around the plant roots. And then when they eat them, that releases those nutrients that the bacteria had within their bodies right there next to the plant roots. So it's pretty crazy. The plant's sort of taking advantage of those nematodes. I do want to mention the term, I'm trying not to be too scientific as we go through this presentation, but the term mineralization may come up, you know, in the future, later in this presentation, and it's an extremely important concept. So mineralization just means taking something from what's called its organic form and turning it into its mineral form. And its mineral form is generally the form that plants can use it. So if a grasshopper, if you just stuck a dead grasshopper in the soil next to a plant root, it couldn't use the nutrients that are in that grasshopper. They're tied up in protein structures and, you know, DNA and all sorts of things that are actually a part of that grasshopper's body, or anything that was living and died. Their nutrients that make up their bodies are not in the form that a plant could take up. So they have to be in a mineral form. And the reason that's important is that's essentially what's going on when things are decomposing and eating organic matter that has died, is that they are either incorporating it into their body, but when they excrete it, they're excreting it in the form of, you know, like phosphate or ammonium that quickly gets turned into nitrate. And then they respire. It's like a metabolism, just like we metabolize things and respire CO2. They respire CO2, so the carbon gets released a lot of times just as CO2. But then the nutrients get released in these little forms that plants can take up. And like we talked about, there's moisture in the soil, and even when we can't see it in very small amounts, unless the soil is bone dry, there's what's called the soil solution, and that's where all those nutrients float around and hang out, and that's how the plants take it up, is through that solution that these are dissolved into. So those are all these living things. If you didn't know already, prove if you didn't believe me. The soil is living. All these living things play direct impact in how the soil is giving us the resources and the services that we expect from it. But then I think a lot of the question of joining a talk like this is, so what do we do as gardeners and as farmers, and just stewards maybe of our yards? What are some ways to protect the soil health and ensure functionality of our soil for our crops and for the future? So that's what we're going to go into. So how can we keep soils healthy and functioning? So managing a soil health, poor soil health, excuse me, and improve soil function is mostly a matter of maintaining suitable habitat for the myriad of creatures that comprise the soil food web we talked about. This can be accomplished by disturbing the soil as little as possible, growing as many different species of plants as practical, keeping living plants in the soil as often as possible, and keeping the soil covered. So this sounds simple, or maybe if you've tried to enact some of these practices, you know that it's not always that simple. But as we go through this, please keep in mind these are important, the as little as possible qualifiers and as practical and as often as possible. We really just want to strive for what we can do within our system and looking for ways of improving these management practices, but a lot of times, you know, it's going to be a balancing act and a give and take for what you're able to do for all of these management practices. And I wanted to add here too, this is when we're talking about soil health, a lot of times it's on the scale of large farms and agriculture. And adding organic matter is possible through some of these practices that we're going to talk about, but a lot of times they're on such a scale that you can't just add a percentage of organic matter. However, if you have a garden in your backyard, or even if you're doing sort of small scale farming, it is possible to add, you know, a significant amount of organic matter, and so we will touch on that at the end. I just want to sort of halfway through here, I wanted to check and make sure, do we have any questions before I move forward?
Nope.
Probably not.
No,
oh, yep.
At least not in the chat, but if anyone has any, feel free to put them in.
Yeah, you can chime in whenever, kind of just running with it. So, but tilling first. So tilling, when you talk about soil health, is often listed as sort of one of the big bad guys in soil health. And part of the reason for that is it is extremely disruptive. Tilling is, if you haven't tilled something before, you can kind of see here in this picture, this is large agriculture, but it turns over the soil, it breaks it up, it exposes it to the air. It's very disruptive to this delicate, symbiotic, elegant, you know, ecosystem that we're talking about. And it's extremely common, and it's hard to get around because it's very helpful in agriculture in a lot of ways, but it is one of the biggest ways you can disturb that ecosystem. So a lot of soil health researchers have been looking at ways to reduce tillage in a lot of different ways, and we're going to talk about some of those ways. I do want to just mention here, you know, we're talking about, oh, it's not supposed to have that picture up yet. Oh, well. Go back with me here.
Hey, Laura.
2 of these ways, yeah.
Real quick. We got a question of what is keeping soil covered mean?
Great question. We are going to talk about several different ways that you can keep soil covered. So it's a good question because it can mean a lot of different things. So one of them, we're going to go into some of these types of no-till and strip tillage. They require that you leave soil matter on, or sorry, crop residue on top of the soil instead of tilling it in. You're actually going to leave it on the soil. So let's say you grew corn or you grew a cover crop, and that's why I'm sort of annoyed I didn't fix this image right here. But if you'll squint with me over here on the far left, without this lady on top of it, this is a no-till system out of Iowa, I believe. So this is them planting, you know, soy or something straight into what was previously a cornfield. So that kind of rubble on the top that was the corn residue from before. And instead of tilling all of that in and incorporating it into the soil and preparing a clean seed bed, they have equipment that will allow you to do no-till, which has a series of different implements that'll cut through that leftover crop residue and plant straight into in between that residue. So that's one way to keep soil covered. You never have just bare. All of y'all have probably, this is about the time of year you may see some of it too, but driven, through some agricultural areas, and you just see acres and acres and acres of soil that's just been turned over. And that's because in preparation for planting a new crop, you usually have to prepare it all, get all the weeds killed back, all the crop residue from the previous crop. You have to turn it up and bury it and incorporate it, and then sometimes even flatten out that soil so that it's easy to plant into. And that's, it's essentially tillage, and that's uncovered. And so it's open to the elements, it's open to moisture being lost, it's open to, I think this is a great time to mention, if you guys know kind of what soil smells like, if you've driven past one of those fields and you've sort of smelled that rich smell of soil, I love the smell, but really what you're smelling is actually that CO2 and that breakdown of carbon. We talked about how when carbon is metabolized, it gets broken down and released as CO2. Well, that's the carbon leaving the soil. So you're exposing a lot of oxygen to the soil, and you're ripping up a lot of those microbial networks, but also the bacteria and the microbes that decompose the soil are getting a flush of oxygen and air, and they're actually just going to start consuming or eating through the carbon that's in there, some of the organic matter that you've built up, and that smell is sort of the release of the carbon. So it's your organic matter leaving the field and going into the air. So that's one issue with tilling as well. Here on you're gonna have to look under this woman to the right, is a tractor doing a strip till system. So it's not the same as just going straight into the rubble, but there's into the debris. There's attachments that have been developed so that you can cut just narrow strips where you're going to be planting your plant, and then that is tilled and prepared, but it's a much smaller area that's getting disturbed and exposed. And then I included this lady on here because most of us, when we're talking about tillage, are not going to be doing it on that scale with the tractors, but certainly in our own gardens, whether it's like a little walk behind, or if you have a slightly smaller, like maybe a small farm that you're managing, a larger kind of walk behind tiller implement, we still till a lot. And it's very important when you're talking about getting rid of weeds and preparing to plant. I mean, I till still, but there are plenty of ways, even though we're not going to be strip tilling or no-till drilling seeds in with our big tractors and attachments. I do want to talk about some ways on a smaller scale that we can either reduce tillage or we can kind of compensate for the damage that's being done when we do have to do that.
Hey, Laura.
Yeah.
You may answer this question as you go through, but we had one question in regards to tilling. And Jackie asks, are you suggesting that when we start a home garden that we do not till the soil prior to planting?
Yes and no. So sometimes it's not possible. And since I just sort of went over why it is so I will go right into that. Tillage is used to kill the weeds. So if you're starting a home garden, you might have just a lawn full of Bermuda and need to start a garden in there. So that's one thing. Of course, tilling Bermuda is a whole nother story, but any weeds, incorporating nutrients. So if you have a bunch of organic matter that you want to turn into your red clay soil, tilling is usually the way you would do that. Managing crop residues like we saw with the corn, or maybe a cover crop. And the whole purpose of this is you may have a very inclement environment to be putting a seed into, and you want to make it into a good, healthy, or happy environment to put a seed into, where it will germinate without competition and with the soil contact and everything else that it needs to be successful. So, if you're starting with this, whether it's in a raised bed or in the ground, or you're starting with that, your goal is to have something like this that you can put little seeds in and they're going to do okay. So sometimes, especially when you're first starting a garden, it's pretty hard to get around tilling. at some point. I would suggest if you're first starting a garden, you just accept that you're going to need to do some tilling at the beginning and maybe have a plan for how to maintain that soil after you get it started. There are some ways in terms of weeds. There are other options for getting rid of weeds. You can solarize them, which is just spreading out plastic, clear plastic during the summer, and you're essentially baking them. That works well in raised beds like this down on the side. Even then, you're going to have a lot of material on the top, just the dead weed material, even if it works really well to kill the seeds and the weeds themselves. But you could do like a little mini strip till in that situation where you clear out little rows for your plants if everything else is dead. You can also use herbicides, and this is a whole nother conversation, but when discussing soil health, it is not cut and dry, and it's not black and white. So a lot of ways of maintaining reduced tillage is using some roundups and things like that in order to not have to constantly be disturbing the soil to kill the weeds. So I would definitely not tell you that you like can't till and to maintain a healthy soil. Sometimes it's pretty necessary, but there are steps you can take in the future of your garden that will help the soil health. If that makes sense. We'll talk about some of those. One of them is cover crops. May sound kind of funny on a garden scale, but you can totally use this concept in your garden or small farm, even on a small scale like a raised bed. The idea of cover crops are multi-fold. So cover crops are basically any plant that you use to keep the ground covered while you're not, planting your normal seasonal crops. This can be another crop that you just decide you're not really going to harvest, but you want to like throw some cowpeas or black-eyed peas out there during the summer if you're not planning on growing anything else. But cover crops will do a lot of different things for you. It keeps the soil covered so it's not being exposed to erosion, either wind or water. It's maintaining moisture. If you have those living roots and plants growing in your soil, you're adding nutrients for that. Remember, you have that ecosystem always in there. So if you decide to just have bare soil for however many weeks or months out of the year, what is that doing to your living ecosystem that relies on plant roots and inputs and not drying out constantly? So you have those plant roots living in there and providing nutrients. You're also adding carbon into your soil with the plant roots. So once you kill that cover crop, you're going to have all those roots that have grown down into your soil that'll then decompose there in place and add organic matter to the soil. And then in the case of a legume, if you're using a legume cover crop, you're actually adding nitrogen because they're nitrogen fixing. And so you're adding some nitrogen pool to your future crops. And then, of course, on top of that, if you have a pretty well-established cover crop during the winter, summer, you're maintaining your clover or your rye or your cowpeas or whatever it is you decide to use instead of just leaving it open and ready for weeds to move in. So it makes weed management all of a sudden a lot easier and can prevent having to do as extreme management of weeds later when you're ready to do your crop. This is a lot of text. I guess mostly it's a placeholder for me. It's part of what we were just talking about. I'm trying to see if there's anything in here that I didn't mention. This is basically just that concept of keeping something growing in the soil all year round, so cover crops are helpful for that. In addition to cover crops, any kind of cover for your soil is going to be helpful for those, what I just mentioned about suppressing weed growth, but also it reduces extremes in temperature. So if you have a bare uncovered soil and you have living things in there, you're in the middle of July, it's going to heat up really hot at the surface and dry out at the surface and then get really wet. And then another thing is with any kind of slope at all, if you have no cover on there, you'd be surprised how much a hard rain like our summer rains will just batter those little aggregates in your soil that you want to maintain, and it'll break those up and it'll create what can turn into either washing the soil away, which is usually the top of your soils where you have a lot of your good organic matter, or breaking up those aggregates and creating sort of a crust that won't allow water to infiltrate in the future. So this is a cover cropped area. So if you're not going to do cover crops, you can certainly also just mulch well in your gardens. So that reduces weeds as well while you're growing things. In between your plants, you're maintaining that temperature buffer, you're breaking up water droplets and allowing them to infiltrate better, you're maintaining the moisture under that mulch. And then a huge thing is weeds. The fewer weeds you have to contend with, the less you have to apply chemicals or disturb the soil. And then this is a type of mulching. It's called sheet mulching, or some people call it like lasagna mulching or composting. And I put this in here because I was recently at a flower farm actually where this woman was doing this, and this is primarily what she does to combat weeds. And she's got Bermuda grass all around her little garden that she has, and she doesn't till at all. So she probably tilled at the beginning to get the garden established, but like that question that we had earlier, you can do things like creating these barriers. So this would be where you're not planting, or unless you wanted to like cut into this and plant into it. But if you want to maintain the areas within and between your plants and around your garden where you don't have to be tilling it constantly, you can put down sheets of newspaper, cardboard, and things like that, and then just keep adding. I think she did that once, if she even ever did it, but mostly she would just keep adding compost and soil on top of the area every year to smother out any weeds that were going to come up, as opposed to doing something like solarization. She was smothering them with soil and compost and not allowing them to kind of get the light and the start that they needed. This is hard. It's like, especially on big areas, but it's a great option if you have the resources. I see a couple more chats. Are we all right with questions?
Yeah, we got one question. What about landscape fabric?
Landscape fabric is totally an option. Most kind of small mid-range growers do something like that for weed control, and that's the same concept really as a mulch, except that the landscape fabric obviously isn't going to break down over time. You likely will have to take it up and put it back down, but it still does a good job of sort of protecting the soil. And again, the number one thing is combating weeds so that you're not having to do really destructive management practices to control those weeds. So certainly, some people have even started using, as a heavier duty, if you need it to last for a while and have a bigger strip, that silt fabric. So you know, the silt fencing that you'll see along the side of construction and the side of the road, they sell that just at Lowe's, and it's sort of a heavier duty fabric. Water is not going to infiltrate some of this stuff as well, so you don't necessarily want to have it over all of your plants, but certainly in the middle of rows or around your gardens or in between. Yeah, you can cut into that stuff and plant too, but you just want to be careful how thick your fabric gets for water infiltration purposes. Compaction is just another thing that you want to be aware of. With farms, you know, a lot of livestock can do serious compaction damage on the soil, and when we talk about compaction, we're essentially talking about those pores, those really important pores that roots grow through and water and air are held in. Those are essentially being squished out. So from over repeated having traffic driven over them or large animals walking on it can really make the soil extremely dense and make it hard for it to absorb water, or if it is soaked, hard for it to drain water. It can make it hard for roots to move towards, harder for microbes to get in there and incorporate organic matter and move through the soil. We probably don't have cows and tractors in our backyard, but we certainly walk through our gardens. We may even drive through our gardens, move equipment through our gardens. So a couple ways that you can help combat that, this is just talking about density and compaction, is either creating permanent pathways in your garden. So on the left here, it's sort of an example of just making sure that you have permanent paths that are okay to walk on and okay to move your equipment through all the time, that isn't going to affect your soil that you're going to one day be planting in. So even if you're not planting there this year, if you're going to plant there next year, you're already hurting your soil pores and increasing compaction and kind of putting yourself behind for if you plant there at a different time. Or if you don't want to have a permanent path in your garden because it's a transitional space, it'll help to do pretty heavy mulching where you know you're going to be walking around and moving equipment, and that mulching will help distribute the pressure of the traffic or walking around that area and not it'll help the compaction in just one spot. It'll distribute that weight out and will help. And then pest control. So plant damaging organisms usually increase when soil organisms decrease. It's sort of weirdly worded. That just goes into that checks and balances thing that I was talking about. It's a whole ecosystem, and if you start to get one side, you know, get rid of a whole bunch of organisms, it's this whole cascade where there's going to be there's going to be organisms that are built to take advantage of those disrupted ecosystems, and a lot of times that can lead to higher pathogen issues because you don't have the checks and balances there. And you also are losing soil function because all these different organisms play different roles. And if you lose a lot of them due to stress or potentially a fumigant or even solarization, then you're losing that function until those organisms build themselves back up. One thing I will say is, you know, solarization is a organic option if you're not going to, you know, the chemicals in terms of getting rid of, let's say you have a pathogen problem, or a lot, nematodes are a huge problem that are hard to get rid of. And a lot of times people either need to fumigate or solarize if they're want to do non-chemical. Solarization and fumigation is going to kill everything in that however many inches of soil that you're targeting, and that's the point. It's killing the pathogen, and everything else, it's non-discriminate, either poison or heat. The good news is either one of these, if you have to do something like that, there has been some research. We did a little bit of research, and those ecosystems will rebuild themselves. I mean, you don't kill everything, and you can kill things to so far down in the soil. So a huge factor in how quickly they rebuilt themselves and the soil function starting up again was adding things like compost, because the compost itself has a lot of microorganisms in it, plus you're creating this conducive atmosphere with organic matter and the factors that those organisms need to sort of rebuild themselves. So we found that adding compost sped up that process. But in general, if you have to fumigate or solarize, it will knock you back a little bit, but those ecosystems rebuild. Crop rotations.
Hey, Laura.
So, yeah.
Before you move on, going back to tillage, we had a question from Ethan. He kind of wants your comments on what he says. He says that he tills in order to reduce soil compaction. He said it's sort of at odds with your earlier discussion on minimizing tillage.
Sure. So so if you have a compacted or just like a hard clay soil, certainly you may need to till. It goes both ways. So that'll break up the soil to an extent, to the depth that you're able to till, and that'll help you get your plants established. It's still disrupting the soil, and it's still disrupting the microbes and the ecosystem that's in there. Sometimes you can't get around it if it's just too hard to plant anything in. I would definitely encourage you to put an organic matter input into there to kind of reduce future soil compaction, or follow some different management so that it's not getting compacted continuously, so you don't have to keep tilling. The issue with tillage and compaction is also, if anybody's heard of a plow pan, is that the tillage implements themselves create a compaction level at about 6 inches or wherever they're tilling. And it's just I don't have my camera on, but the process of those tines rolling over in the soil, it fluffs up the soil to the depth that you're able to till, but it's actually hitting and compacting this layer at about usually 6 to 8 inches, that a lot of farm soils have a compacted layer there still, if they have a history of agriculture, because of all of the tillage. So sometimes you can't help but till to get things started, but I would encourage you to, you could plant deep-rooted crops. You can come up with ways to maybe reduce tillage in the future. It's kind of expensive to be using new farm equipment, but there are certainly attachments and things that are specific for breaking up those plow pans, but they don't do the same action that regular tillers do. I don't know if that answers the question. It is always a give and take. Tilling is very helpful for agriculture, but the idea is that minimizing it in any way that we can is very helpful to soil health. That makes sense. Crop rotation is another management I want to throw in here for soil health. It's helpful for gardening in general because what it's going to do is it's going to break the life cycle of a lot of pests and pathogens that want to eat your plants. So I like this image. It was from a Princeton student that did a project, and this was on one of their websites. I think it's kind of funny that they call it the potato family. I have not seen that before. It's the solanaceous family. It includes potatoes and tomatoes and peppers and a lot of other and eggplants and things that you're familiar with. So, but the idea here is when you're doing a crop rotation, the idea is to try to keep the same family out of the same spot for as long as possible. So the legumes are kind of their own family. Brassicas are a big family that include all these things listed here. Roots are not really all the same family, but some of them are related, and a lot of them have similar pathogens and pests, so they are often grouped together. And then the solanaceous family are those things that I mentioned, including peppers and eggplants. And so if you can keep, whether it's raised beds that you're moving around or garden beds or a farm, if you can try not to plant the same families in the same spot for as long as possible, you're going to greatly reduce your pressure of pathogens and even insect pests that are building up in that spot, which can then allow you to not have to spray as many chemicals and obviously helps your disease pressure and can increase biological diversity because different microbes are associated with different plants. So you're giving that soil a lot of different inputs from different types of plants. And nutrient availability in terms of not overloading your soil with fertilizer, because legumes are going to oftentimes they add nitrogen to the soil, especially if you can leave some of the residue in the soil. Brassicas tend to be pretty heavy feeders, so that's probably why they have them following the legumes in this example. By heavy feeders, we just mean they need a lot of nutrients. And so also you're just kind of diversifying what plants are going to be sucking what nutrients out of the soil, so you don't have something that needs a ton of nitrogen right after something that needs a ton of nitrogen right after something that needs a ton of nitrogen.
Hey, Laura.
Yeah.
We've got a question. What is the period of months or whenever for crop rotation?
It's going to be seasonal. So, I wish I had included like an example chart here. So usually for crop rotation, you're talking about planning for like years in advance. So you have like a 3 to 5 year plan sometimes where you have little charts and you say, this year I'm going to grow brassicas here, but brassicas are a cool season crop. So you're going to have little boxes for like each season, but repeated for multiple years. And it's basically, you can decide what summer crop are you going to follow brassicas with, and that might be like corn or something. But I wouldn't do that because they're also a heavy feeder. You know, let's say you could put the eggplants and stuff after the brassicas. It really doesn't. I guess it doesn't matter. I don't know. I guess the months are just gonna depend on how long those crops are growing for. But I don't know if this answers your question, but it is important to consider if you really want to see results in breaking disease and pathogen cycles. You're talking about trying to keep like the same family out of that spot for 3 or more years. And that's difficult to do sometimes, especially if you don't have a lot of land, and especially if you're not trying to grow that many different things. But very general recommendations for breaking some of the life cycles of these pests is like, if you can keep that same family out of that one spot for 3 years before having the same family grow there again. And more is better. Oh, and this may also include, let's say you don't want to grow that many things, you can't manage that many things, doing fallow. So meaning just not growing something there, or even better, instead of fallow, you would just have like a cover crop on that before you decide to go back to brassicas or tomatoes or whatever you want to grow. This is just the points that we talked about before, and it's not linear. So I broke it down like this. We talked about ways of managing for soil health. One being disturb the soil as little as possible. So some ways of doing that are reducing tillage by either doing no-till or strip till, or trying to maintain a weed-free area so you don't have to till a lot, or incorporating organic matter when you do till so that the compaction is reduced. You don't have to till more later. Reduced compaction is also considered less disturbance of that soil system physically. and then reduced chemical inputs by doing things like crop rotations or cover crops or anything to reduce pest pressure and weed pressure. Grow as many different species of plants as practical. So we didn't cover that as much because that is usually harder to do when you're on a larger scale. A lot of us in our gardens want to have a lot of different things growing, but some things that we can consider are doing cover crops if we're not going to be growing something there. Instead of just leaving it open and bare, we can grow a cover crop. And we can also implement crop rotations to try to get a diversity of different types of plants growing in our soil instead of growing the same thing in the same spot all the time. Keep living plants in the soil as often as possible. That would be cover crops and crop rotations, and keep the soil covered, which is a great, that first question. That could be cover crops, reduced tillage, and any kind of mulching. So that was a lot of management practices, and a lot of those were sort of cultural management that we can do, so things that we can adjust in the way that we manage our soil. But obviously another huge aspect of soil management is amendments, so things that we're adding to our soil. And this is especially relevant when we're talking about this scale, sort of the backyard scale or the small farm scale. There's a lot more we can do in terms of amendments a lot of times than if you're talking about hundreds of acres. So we are going to spend the next, how many slides? 10 or so slides going through fairly quickly things that you add to your soil and why and how, and taking a soil test to help you decide what you need to add to your soil. So this slide is not really meant for you to read the whole thing. I mean, please feel free. I'm going to go through some of it, but the point is just really to drive home the concept that organic matter is going to be your best friend when you're talking about soil amendment. If you can add organic matter to your soil, add organic matter to your soil. There's almost no limit to how much you can add and how much it'll keep helping. So organic matter helps physical components of the soil with the aggregate stability that we were talking about, water holding capacity. It reduces compaction and crusting. It has chemical benefits, which we're going to go into very briefly in terms of increasing the soil CEC, or that's really the amount of fertility that a soil can maintain, highly affected by organic matter. It improves soil's ability to resist pH change, so you'll hear that called buffering capacity. So it maintains the pH that you want by having more organic matter. It accelerates decomposition. It provides a lot of microbial habitat and food and environment for all of these living things that we were just talking about. It's awesome. I mean, just add organic matter and it'll help everything. I really mean it. Quickly, this is not a soil science, soil chemistry class, but cation exchange capacity sounds really daunting. It's referred to as CEC. You may have seen that. But I do want to mention the reason that organic matter plays such an important role in when we're talking about fertility and pH buffering is all because of CEC. So very basically, CEC is just the ability for a soil to maintain fertility. And it's all just, if you like, the breaking down the term is soil nutrients. When they're in their mineral form, like we talked about, and they're available to the plants, it's because they're dissolved in the soil solution, the water, and they all have an electrical charge. So they're all dissolved and they all have charges. And a lot of important soil nutrients have positive charges. So that is called the cation. And so the cation exchange capacity is just the ability for soils or a soil particle to be able to hold on to and release those nutrients, those charged nutrients. There's also anion exchange capacity. It's just the opposite. It's for negatively charged things. So the point is, clays actually have great cation exchange capacity compared to like a sand. If you look up here, sand, these are just units, don't worry about it, but 1 to 5 units. And clay is down here at like more than 30, so it's much better than sand. But if you look at organic matter per particle of organic matter, it's exponentially greater. So organic matter, because of the way that it's formed or the complexity of the molecules, it can hold on to and maintain just an enormous amount of nutrients in terms of just its energy, can attract them and hold them much better than many other soil particles. So that's one of the reasons it's usually associated with fertility. It's not that organic matter has that many nutrients in it, that it can hold the nutrients. It is important because carbon is needed to process a lot of these nutrients, like through the biological food web. And compost and manure provide a lot of carbon. However, when we talk about fertilizing our soil and we talk about compost, I think a lot of people think it adds a lot more nutrients than it does. Compost itself is fantastic. I hope I made that really clear. Compost is very good for the soil and it helps a lot of things. But if you're looking here, this is from Cornell. Sorry, it's a little fuzzy, but this is just looking at composted poultry manure, yard waste sort of compost, and then crop, like if you were to compost your crop residue, and how much nitrogen, phosphorus, and potassium is available in that compost. So just to give you like a comparison, if you've ever used a fertilizer in a bag, it's like a 10-10-10 or something. That means it's 10% nitrogen, 10% phosphorus, and 10% potassium. They make 34-0-0, like 34% nitrogen. When you're looking at compost, like a regular, crop residue compost, you're looking at around 1 to 2%. So it really doesn't have a whole lot of those nutrients in it per se. So it's going to be hard to reach your nutrient balance just by adding compost. That's just the point I wanted to make. And then also, very little of that compost is in mineral form. So even that 1 or 2% that's even there is not going to be available immediately. It's going to take a long time for bacteria and fungi to break it down before it's even available to the plants. This is a lot of numbers and a lot of things, but this is just making that comparison a little bit further. Over here on the left, this is like a lot of common commercial or mineral fertilizers and the percentage of nitrogen and phosphorus or phosphate and potassium and things that they are. So like anhydrous ammonia is 47%, or sorry, 82% nitrogen, urea is 46%. Ammonium sulfate is pretty common. That's like 21% nitrogen. Ammonium nitrate 34%. Compared to like 1%, and that 1 or 2% is not even available right when you put it on there. Having said that, it's not that there aren't organic options. This over here on the right is the beginning of a longer chart that just includes, this is from the University of Georgia, has a great publication on organic fertility management. And this is a chart in there, and it shows a lot of organic options. And again, this is maybe half of the chart, but you get up to a lot closer. So fish meal or something like that would be 10% nitrogen, 4% phosphorus. If you needed, it doesn't have it on this, but it goes into potash and other things like that. Alfalfa meal is 3. So you can look on here and find out what you could use organically to meet those different nutrient requirements. But a lot of times, just compost may not do it for vegetable gardening. So how do you know what you have and what you need? Soil testing. Soil testing is huge no matter what scale you're growing on. It changes seasonally all the time, what's in your soil and what, the balance between those nutrients and the pH. So I just want to encourage anybody who is growing anything and hasn't done a soil test, please do it. And I don't want you to be afraid of it. So we're just going to kind of go over real quickly. You're just going to want to do random tests. You guys can call me if you have further questions because I want to get to the last couple slides. If you want to randomize it and get a couple subsamples to get a nice mix in there when you're doing your sampling. And then the report you're going to get is going to look something like this. So when you give us the report, you're going to say what kind of crop or lawn or whatever it is you're growing. Right here, it's tall fescue. This is actually something I did for my parents, said my name on it. And this is what it's going to spit out. And it looks a little complicated and intimidating, but it's not too bad. I think the first number I'm going to ask everybody to look at when they get their soil test is the pH here. And the reason that's so important is because pH is going to affect no matter how many nutrients you have in the soil. We talked about that solution and the chemistry of it. If you don't have the right pH, those are just not going to be available. So they may be there, you can add hundreds of pounds of something, but it's just not going to be in the form that the plants need. So it's going to give you a lime requirement. And that's, a lot of people ask about, can you just do a pH test at home, or like you can buy this little pH test. I would encourage you not to. It's really not expensive to get a soil test. And the problem is the accuracy. So if you're just off a little bit on a pH test, it makes a tenfold difference because it's on a log scale. The other reason is because when they give this lime requirement at the lab, they're including a buffering capacity of your soil. So that's a separate test that they do. And we talked about how soil organic matter buffers soil. So clays do also. But anything that has those electrical charges will actually make it harder for you to change your pH for better or worse. So if you're trying to bring your pH up and your soil has a really high buffering capacity, then you're actually going to need more lime than if somebody else next door had a different buffering capacity. So I encourage you to get it tested and find out how much you really need. And if you haven't seen, if you haven't seen this before, this is just that image depiction of why pH is important. So these are a bunch of the soil nutrients, and then this is the pH here along the bottom, and the square is right in that sweet spot of where most of these nutrients are most available. And I won't go into why they are bound up below and above this range, but just take our word for it. This is very general, the 6.2 to 7.3. That's not going to be the case with everything. That's pretty ideal for most vegetable crops, but there are certainly other crops and fruit crops and ornamental crops and grasses, and everything's a little different, but it will take that into account when you tell the soil lab what you're trying to grow. It'll give you the range that they recommend for that crop. And then this is back to that same thing, and I just want to mention the other thing that it's going to probably spit out is a recommendation for adding fertilizer. So if you haven't looked at fertilizer recommendations before, or bags of fertilizer, the three numbers that you're going to see either on your bag of fertilizer or on your soil test results stand for N, P, and K. So this is 15-0-15. So that's 15% nitrogen, 0% phosphorus, 15% potassium. It's recommending 10 pounds of a fertilizer that has that makeup, or whatever the numbers might be. And if it's hard for you, the N is pretty easy for nitrogen, and then the phosphorus and potassium a little bit trickier because both of them start with P in English language and not Latin. So I just think of phosphorus first, if that helps. So nitrogen, phosphorus, potassium are those three numbers. So I want to leave a little bit of time for questions, but quickly, I do want to mention here this little link that I put down here, and we can send some resources out in our follow-up email, especially if there's something in particular that y'all want. Let us know in the chat before we leave. But this little link will be at the end of your soil analysis, and it is a calculator. So a lot of people ask, if you have a weird shape, or you want to use an organic amendment and it's not a 10-10-10, how do you decide how much of that amendment you use? And this calculator is great, and you can always call your extension agent if you need more specific help, but this is a good thing to play around with first. And so what this does is you can put down here, let's say you had compost that you made yourself or you got from a neighbor. You can have the compost analyzed and see what its nutrient breakdown is, and you can put the numbers in here and use your actual specific compost components. Or you can just use a general, like what compost usually is, and I have that somewhere, I don't think it's on here, but you can just use an average. Or let's say you went to the store and you got blood meal or cottonseed meal, or you have a fertilizer or an organic fertilizer that was sold to you and it says on the bag 1477 or something. You can click all of these. Oops, this is not a real page, it's an image, but you can click what you have available to you, all the different things you have available, and you can put in the recommendation that was given to you in your soil test results, and then the calculate button is down here normally. You can calculate it and it'll spit out like the closest approximation. You may have a little bit of a deficit or a little bit too much this nutrient or that nutrient, but it'll give you the best approximation of using this many pounds of this many pounds of that to come up to the recommendation that was given to you for a regular over-the-counter mineral fertilizer. It's very useful, this calculator, especially for organics. Okay, my voice is about gone, and I still have about 12 minutes. Honestly, I'll stay longer if y'all have more questions, but now we just have time for questions.
Thank you, Laura. So I saved a couple from earlier. The first one is from John, and he asks, or he says he's concerned about this was when you were talking about tilling at the beginning. He's concerned about the herbicide, Roundup, and polluting the groundwater.
Yeah, so there's been entire talks recently given actually by our native plant coalition here, because Roundup has to be used pretty often in invasive weed removal. So they've done some of the most in-depth talks on Roundup that I've seen. And I've spent some time looking into it, and there's been a lot of discussions about it. Basically, if Roundup is used according to the label, and this is the case honestly with all chemicals, they're scrutinized pretty heavily in terms of proper usage and what their impacts are going to be. But I will say Roundup, more than many other herbicides that are out there, dissipate very quickly in the soil. So their components are actually broken down in the soil almost immediately, very quickly after they're applied. They do not exist very well when they come in contact with soil. So if you're following the application directions in any, there are different glyphosate formulations, so you have to follow every label specifically to whatever product that is. But it really doesn't stick around in the soil for very long enough to have much impact. A lot of the controversy over Roundup has been personal safety, because there's been a lot of claims that it's not harmful at all, and then people will use it in ways that were not listed on the label, and there have been consequences to that. So I 100% respect using as few chemicals as possible, but I will say of the chemicals that are out there and the herbicides that are out there, Roundup is not very persistent in the environment.
Awesome.
Answer that.
And then when you were discussing cover crops, we had a question in regards to kind of the homeowner cover crop. So how would you address your cover crops once you're ready to plant? Also,
great question.
And this might be a separate question, but also how would you recommend to incorporate them in a raised bed since you won't be mowing?
Those are, great questions. I should have spent a minute on that when we were going through the cover cropping. So, and this sort of also speaks to the Roundup question. So there are different ways of killing plants, whether it's a cover crop or a weed. So most people, when they're doing cover crops, they will either mow them, or they will roll them, crimp them as another option, or you can use an herbicide to kill them. And those are the three main ways that what they call terminate a cover crop. And what I will say in order to sort of answer this succinctly is that there are great resources, especially actually through SARE has a great online resource for cover crops and which ones are the best ones. And it'll go through planting and establishment and management and what they do for you, but it has a whole section on the way you terminate those crops. So depending on what you're using, it'll respond to you actually can use a little weed whacker if you're using like a raised bed, and it recommends mowing. You can do just like weed whack it down to the ground instead of mowing it with a lawnmower. And some of them, if it's a lot of times these taller grasses, you can just break them over when they get to the point of termination, and that'll do it. And some crops will not, they will just keep living through that. So you would have to look at the recommendation for specific cover crops. But if you're trying to Google that, it's cover crop termination, and then whatever plant you decide to plant for your cover crop.
Yeah, we got a couple people asking about recommendations for cover crops and lists for cover crops. So I thought we could probably include some of those resources in the post-class
we can include some good resources on cover crop options, and that will include all that termination and management information. I'm still totally open for questions. I forgot to put up this last slide here too. This includes a link to the end of class evaluation, which we'll be sending out in an email if you registered with us, along with those resources that we'll compile for some of the stuff that we talked about. We also want to advertise our upcoming Green Thumb lecture in November. It's going to be pretty great. It's given by one of our master gardeners who works very closely with native plants and landscaping. And so he's going to go through a lot of native plant information, how you can use them in the landscape and how you may manage them and what you would use them for and all different species. I'm very excited about it. And am I missing something, Joanna?
No, we just have more questions.
Yeah, I just want to, I always forget to mention those things.
My email is covered up on that. I guess I didn't notice that when I edited it, but I'll put my email in the chat for everybody if you didn't register and you want to get that post-class email.
Okay, thanks.
Mm-hmm. And then a question that we've had recently, and I'm sorry if I mispronounce your name, but I want to try to at least say it. I think it's Maha, maybe that's how you say your name. But they ask, do you have any schedules / recommendations we as homeowners can do the weed control?
Yeah, so just for weed management recommendations, that's something that I may be able to include in the follow-up email in terms of, I mean, it depends a little bit on what you're growing in terms of weed management. I mean, I'm happy for a follow-up. Are you thinking you're going to use any chemical weed control? Are you growing a lawn, or are you growing more of a vegetable garden or garden?
The lawn.
Okay, for you. Yeah, absolutely. There's some great ones. If you will send us an email, and again, I know that that's covered up, but I think the email that Joanna put in the chat, and let us know what kind of lawn you have, then we can send you some specific seasonal weed control options and management strategies. Yeah.
Thank you. I'll send an email. Thank you.
Mm-hmm.
And we also have a question from Caitlin and Shep. Do fertilizers and lime need to be tilled into the soil or just sprinkled on top of the soil?
Oh, that's a good one. So yeah, that's another thing that people use tillage for a lot, and especially for lime, well, really for both. It depends on what kind of fertilizer you're using, but lime, it does help to till it, and you do not have to. Surface application is totally fine for lime. It'll take it longer. It's a pretty slow dissolver, so it'll take it longer to work its way deeper into the soil. That's why actually right now is a great time to do a soil test, because if you're planning on planting like a spring garden and you're trying to get, or a lawn or anything, and trying to get your pH up to, maybe it needs to be a little bit higher, even if you surface apply now and let the rain kind of work the lime down and let it dissociate and dissolve in the soil and work for the next few months, then that'll give you some time for that to work. If you're in more of a hurry and you have like a really low pH and need to bring it up, 6 inches down pretty fast, it is better to incorporate, which is just a euphemism for till, into the soil for lime. For fertilizers, it depends on what kind of fertilizer. If you have something that is not designed to be sprinkled on the surface and it's high nitrogen, you risk losing a lot of the nitrogen off of the surface, because when it combines with water, if it's not under the soil, then it will volatilize as ammonia. It'll go from ammonium to ammonia pretty quickly, and it can just sort of dissolve, just evaporate. Having said that, a lot of composts, it's nice to incorporate them in, but you can certainly surface apply compost, and there are certain fertilizers that are designed that are okay to surface apply, but it's the same kind of thing. A lot of times it's better to incorporate. So I would say if you're going to have to till for something, maybe, if you're tilling in preparation for planting a lawn or something, and you're going to have to do that prep tilling, get a soil test in preparation for that, so you can incorporate the lime when you do that. So you don't have to, but it does help.
All right. Well, I think that was all the questions. If I missed you, though, please shout out or put it back in the chat. I'm pretty sure I got everything.
Thanks for keeping an eye on that, Joanna. And
yeah.
If y'all think of something in the the next couple of days, preferably the next day or so before we send out the follow-up email, or if there's a resource that you saw that I mentioned that you'd like on there, just feel free to shoot us an email, and we will put that resource in the email.